Hi and welcome to this Leaving Cert Higher Level Applied Maths video. In this video, we're going to look at a previous exam question. So this question comes from the 2023 Higher Level paper. It's question 7, part B. A learning curve is a graphical representation of how a person's ability to perform a certain task increases with the time the person spends learning or practicing that task. A student wishes to be able to spell 2,000 difficult words. The rate of the student's learning may be modeled by this difference equation, which is dn dt is equal to k times 2,000 minus n, where n of t is the number of these words the student is able to spell after t hours of learning, and k is a positive constant. At the start of their learning, students will already be able to spell 250 of these words, i.e. n of 0 is equal to 250. When t equals 0, n equals 250. Solve the differential equation to find an expression for n in terms of k and t. So step 1, because we've been given the differential equation, is to separate it out so we have different variables on each side. So we're going to bring the n's to the left-hand side. So I'm going to bring this whole bracket across. So I get 1 over 2,000 minus n dn is equal to k dt. And we're going to integrate both sides. And when t is 0, we were told that n is equal to 250, and we were trying to find an expression for n in terms of t. We're not subbing in for our k. So the left-hand side is a version of a plus ax plus b, or some version of that we're integrating, which is a more complicated version of just 1 over x. So when we integrate that, we'll do 1 over x first, we get ln x. When we integrate 1 over ax plus b, we get ln ax plus b. But because it's more complicated, we're effectively using the chain rule in reverse. We have to divide by the derivative of the inner function. B is a constant, so it disappears. Ax just goes to a. So it's all over a, or another way to write that is 1 over a ln ax plus b. This is a really common one, so do watch out for it. So we have here on the left-hand side the natural log of 2,000 minus n. Be really careful here. You might think there's no coefficient of n, but there's actually a minus. So we're going to divide by a -1, which effectively just makes this negative. We're going to evaluate that between 250 and n. On the right-hand side, we get kt, which is between 0 and t. So then we get minus the natural log of 2,000 minus n minus the minus, which gives us plus, natural log of 2,000 minus 250, and that equals 2 kt. So what we get, if you want to kind of pull that minus out in front, we can do kt equals minus, and then we can do the natural log of 2,000 minus n all over 2,000 minus 250, which is 1750. That is exactly the same as the natural log of 1,750 over 2,000 minus n. So you're absolutely fine to do that whichever way you prefer. We're trying to find n, so I'm going to flip this. So the ln 2,000 minus n all over 1750 is equal to minus kt. We're going to take e to a power on both sides, which is going to leave us 2,000 minus n over 1750 is equal to e minus kt. And that's 2,000 minus n is equal to 1750 e to the power minus kt. N is equal to 2,000, watch your signs here, minus 1750 e to the power minus kt. So for part 2, we're told after 6 hours of learning, the student is able to spell 1,500 of these words. Calculate k. So we have our formula here that we worked out from part 1. However, because we're looking for k, we can go back to part 1 and go through our workings and see, is there a line which will help us to isolate what we want. So in this case, K, rather than us having to put in the values and then work backwards. It's absolutely fine to put in the values and work backwards. So our values are when T equals 6, N equals 1500. But in order to work backwards, it's going to take a few steps. So going back to part 1, we can find the line that reads KT. Well, ours reads slightly backwards. So KT equals minus natural log 2000 minus N 2000 minus 250. And there's a minus in there at the front. So we can use that instead because that's going to be much, much easier for us to isolate our K. So to get K, it's going to be minus the natural log of 2000 minus 1500 all over 1750. We can do a little bit of cleanup on that, and then we're going to divide that whole thing by 6 very, very quickly. We end up with the natural log of 2 over, sorry. So we can tidy that. Actually, do you know what? I'm not even going to tidy it up. I'm going to go straight to my answer, which is 209 at 0.209. So lovely and quick. So part 3 asks us to sketch the shape of a graph of n against t to show the model's prediction for the student's learning curve. So there's a few different ways you can work that out. In your calculator, you can put in the formula and you can just change your t value from 0 to 5, 10, and so on. You can use the table function if you've a Casio or the function on other calculators. So I'm going to create a table just so you can see the values. So when t is 0, we get 250. You don't need to do this. However, it might be helpful for yourself to have these written down just rather than going straight to plotting. Once you have these, we're going to start plotting the points. So that's 0, 250. This is 5 and 1385-ish. This is 10 and 1784. This is 15 and 1924. This is 20 and 1973. And then we have 25 and 1991. And our final point is 1997 with our t equals 30. And we're going to do our sketch, which gives us a graph that looks like this.